Before we start this video, I'd like to give a huge shout out to Keyshot, who have recently sponsored us. They make amazing rendering and animation software that you can check out at keyshot.com. They've finally given us free access to their amazing rendering software, which we're going to use to professionally show off our cars. Their software is easy to use and creates professional results, which will allow us to present our cars to the judges in the EDR and portfolios. Check out our website www.teammile.in, where we'll soon be uploading our first renders of our car.
Hi, this is Seb, a design engineer of Team Mile. Welcome to our video on shapes and airflow, part of the Aerodynamics series. The shapes of aspects of your car will greatly affect the air's flow and passage around your car, influence the speed of your car through the design's drag, as well as the turbulence generated. The core concept to understand in airflow and aerodynamics generally is the boundary layer effect, or the ground effect. This basically states that there'll be an unmoving boundary around an object in motion that will cause air coming into contact with the object to in fact not collide with the object itself, but with the boundary layer. This can then be used to reduce drag on the car by exploiting this effect. But what shapes will work on my car? Let's take a look at some examples. First of all is the most basic of all shapes you must learn about in aerodynamics, the aerofoil. This has high velocity and low pressure on top, with high pressure and low velocity on the bottom. This aerofoil has four main elements that determine its effect on the air. The chord is the length from the leading edge to the trailing edge. The maximum thickness is the maximum height of the aerofoil perpendicular to the chord line. The angle of attack is the orientation of the aerofoil. One with a high, positive angle of attack will force air beneath it, causing lift, while one with a negative angle of attack will cause downforce. Though downforce is a large priority in Formula 1, it is not necessary for F1 schools, as the competition lacks the turns present in the former. The teardrop is the most aerodynamic shape in nature and has extremely low drag and turbulence generated. This means that it has garnered mainstream use in long-range, low-fuel competitions, as well as cars such as the Aptera EV car design. The next shape is a circle. This is not used widely in F1 or F1 schools, due to the high turbulence generated behind the shape. However, its front end works well with a low drag coefficient, and this part of the shape can be used in shapes such as the teardrop or the aerofoil.
The next shape we'll look at is the square. The square shown on screen will require more energy for the air to move around. It has the highest drag coefficient of the shapes and has high turbidity behind the shape.
Thank you for listening, and we hope that you enjoyed. Make sure to check out our other videos in the Aerodynamics series.